So what is it that's inside of this R box now? Because that is a function that's hardwired into the standard, just like the F function in DES. Keep in mind that our current mixture is 128 bits, starting from the plain text, and we can view that as an array of bytes that is 4 by 4 long. So 4 by 4 is 16, times 8 bytes is that 128 bits. And the plain text serves as that initial state. We get to the next state, going from 0 to 11, by taking the current state, performing a substitution that is going to be defined by a table, then shifting rows independently in this matrix, and then mixing columns independently in the matrix. And after we do all of that, then we XOR it with an element from the key schedule. So that's R, defined in terms of mixed columns, shift rows, and subbytes. We'll dive into those functions in a moment, but first, the R prime that is used for that last step of AES omits the mixed column step because it doesn't make things look any more random than it would be without it. And there's no next step for that mixture to contribute to. So let's look now at subbytes. The subbytes function is defined by this big table. 0 is mapped to hex 63, 1 is mapped to hex 7c, and so on. And if you carefully study this table, you will discover that every number from 0 to 255 is represented exactly once in the table, so it's a bijection, a one-to-one mapping that we can reverse as we need to decrypt. The shift rows function rotates each row individually. It actually leaves the first row alone. It moves the second row one step to the left, wrapping around, the third row 2 steps to the left, more equivalently 2 steps to the right, wrapping around, and the last row 1 step to the right with wraparound. So it takes rows that look like this and produces rows that look like this. You can see what's happening is we're changing the alignment of the rows so that we have a mixture of things in columns, and that sets us up for the next step, to mix columns. Meanwhile, shift rows itself is clearly reversible, just like subbytes. The mixed column step is going to take a column like this and produce a new column like that by multiplying the column by this matrix here. I put multiplies in quotes here because it's not the usual multiplication on an integer. Instead, it's multiplication on a different related group. But it has similar nice properties as multiplication by integers, which is that this matrix multiplication can be reversed, so we could take the result of the multiplication and get back again to the original here. Meanwhile, it's mixing up columns and taking advantage of the fact that we shifted different rows around to get different pieces of the original input into different columns. So again, around an AES is applying each of those 3 reversible functions, which means that the overall combination is also reversible.